Hi and hello to everyone. In this video, we are going to see the applications of Z transform. In the applications of Z transform, we'll be finding out the system function that is also called transfer function for a discrete time system. From a given difference equation, we'll be finding the system function or called transfer function. We'll be finding the impulse response and we will also finding the other responses like step response as well as the frequency response. Finally, we'll conclude with what is the relationship between the discrete Fourier transform and Z transform. Welcome to the lecture. First question: for the given system, for the given difference equation relating the input and output, this is the equation given. Okay, since it's a difference equation, it should be a discrete time system. Discrete time system is represented by the difference equation. The question is find the system function, find the impulse response, find the step response. Right? Okay. First thing, what is system function? System function is nothing but Z transform of the output by the Z transform of the input. Okay. Here the input is X, output is Y. Fine. Right. Now we have to take the Z transform for the given difference equation. For Y of n, the Z transform is capital Y of Z. So 7 into Y of n minus 1. Okay, time is shifted by 1. So I have to put Z power minus 1 Y of Z minus 12 into Y of n minus 2. So n minus 2 it is coming. So Z power minus 2 Y of Z. So 2 into X of 1. So 2 into X of Z. X of n minus 2. So Z power minus 2 X of Z. Okay, this is nothing but using the time shifting property, right? Z transform of Y of n is Y of Z. Z transform of X of n is X of Z. If it is shifted by minus 2 units, shifted by minus 2, shifted by minus 1 unit, what you have to do? How much time it is shifted? You just put Z power minus 1. Y of n minus 2 means Z power minus 2. X of n minus 2 means Z power minus 2 into X of Z. Okay, so this is the Z transform of the given difference equation. Okay, now we need output by input. So y by x. So bring all y terms to the left side, keep all x term in the right side. Okay, bring the y term to the left side. So take y commonly outside. In the right side, you take x commonly outside. So y by x is equal to 2 by 2 minus z power minus 2 divided by 1 minus 7 z power minus 1 plus 7 z power minus 2. Right, now here it is in the power Z power is in negative. Okay, so this is also a correct answer of system function, but still if it is in Z power positive, it will be more convenient to solve and read. Okay, so for that purpose you have to look what is the maximum power of Z in negative in the numerator and denominator. In the numerator is Z power minus 2, in the denominator is Z power minus 2. Okay, you have to take the maximum power and you have to multiply with the positive Z power such that the negative powers get cancelled. So here Z power minus 2, here Z power minus 2. So I have to multiply with Z square and I have to divide by Z square. Okay. Suppose if it is Z power minus 3 means what in the denominator is Z power minus 3 means what you have to do? Multiply by Z cube, divide by Z cube. Okay, for the maximum power, you have to multiply such that the negative powers of Z becomes 1. Okay, so you multiplying the numerator by Z square, it becomes 2Z square minus 1. Multiplying the denominator by Z square, so 1 into Z square, Z square. 7 into Z power minus 1 into Z square, 1 Z gets cancelled out, so some minus 7 into Z plus 12 into Z power minus 2 into Z square, Z power minus 2 Z square gets cancelled, so it becomes 1. So we have only 12. Okay, just we have multiplied the numerator and denominator by Z square. We get this. This is called system function or called transfer function. Okay, now we will find out the impulse response. For finding out the impulse response, okay, what is the impulse response? What is system function h of z is represented by h of z. Y of system function is h of z. Out y of z by x of z is this. Okay, so what is the output? Output is y is equal to bring x to the left side. So system function into x. So system function into x is the x of z is the output. Okay, our question is find the impulse response. Impulse response is generally represented by h of n. Okay, right. Because transfer system function is h of z, inverse z transform is h of n. The question is find the impulse response. What is impulse response? Impulse response means output. Okay. Impulse response means if the input x is impulse delta of n, x of n equal delta of n, the output is called impulse response h of n. Okay, so input is impulse. So x of n equal to delta of n. So what is the Z transform of impulse signal? Z transform of the impulse signal is 1. Okay, so output y of z equal to h of z because x of z becomes 1. Right? Now the thing is, this is my h of z. I can see very important thing. We have to multiply numerator denominator by z. Okay, because we'll see later why we are doing that. Okay, you see later, right? Here what I am doing, multiplying numerator and denominator by z. Then I factorize this, z square minus 7z plus 2 plus 12 can be factorized as z minus 3 into z minus 4. Okay, so bring this z to the left side. So h of z by z is equal to this term. Okay, so what are the poles? Z equal to 0, z equal to 3, z equal to 4. These are the poles. So we have three constant a, b and c. So this is what we are here now. So h of z by z is equal to 2z square minus 1 by z into z minus 3 into z minus 4. So they are simple poles. So a by z plus b by z minus 3 plus c by z minus 4. Okay, now our objective is to find out what is the constant a, b and c. So daily partial fraction I have to write down like this. So you have to cross multiply z minus 3 z minus 4 plus b into z minus 4 plus c into z minus 3. Okay, we have to find a. To find a, we have to cancel the c term, b and the c term, right? So if we put z equal to 0, 0 into b is 0, c into 0 is 0, only a will get. Okay, so put z equal to 0, so 2 into z square, so 0 square is 0, so minus 1 equal to a, 0 minus 3 is minus 3, 0 minus 4 is minus 4. So minus 3 into minus 4 is plus 12, so a equal to minus 1 by 12. This is my a. Okay, now to obtain b, I have to cancel a and c. So look for what value of z, a and c will become 0. Okay, so here z minus 3, z minus 3. So if I put z equal to 3, z equal to 3, what happens? This becomes 0. Z minus 3, put z equal to 3 here, this becomes 0. Okay, now a and c has become 0. Now you put z equal to 3. So 3 square is 9, 9 into 2 is 18, 18 minus 1 is 17, 17 equal to b into 3, minus 3 minus 4 is minus 1. So b equal to minus 17 by 3. Okay, now we have to find z equal to, we have to put z equal to 4. Okay, think we have to cancel a and b. Here we have z minus 4, so z minus 4. So if you put z equal to 4, 4 minus 4 is 0. Here 4 minus 4 is 0. So a becomes 0. B is also becoming 0. Okay. So put z equal to 4. These two terms become a and b become 0. So here we have 4 square is 16. 16 into 2 is 32. 32 minus 1 is 31 equal to c into 4 minus 4 into 4 minus 3. 4 minus 3 is 1. So c is 31 by 4. Okay. Now substitute a, b, c. Substitute a, b, c here, right? So a is minus 1 by 12, b is minus 17 by 3, c is 31 by 4. We got this, right? Now you understand the importance of taking the z to the denominator in the left side. Now we bring to the z to the right side. Okay, so z comes to the right side, z by z is 1, so minus 1 by 12. This becomes z by z minus 3, this becomes z by z minus 4. Okay, now you can understand why we have taken when you have taken the one z to the left side, then only we can get the proper z transform pair. For that purpose only, in the previous slide I have taken this z to the denominator in the left side. This is very important step. We have to write h of z by z. Okay, then we proceed. After taking partial fraction, bring this z to the right side in the numerator. Okay, now we have taken this z to the numerator. We got this. Okay, now we are going to find the solution. Find the inverse. Then we have h of z. So impulse response is h of n. Inverse z transform h of n. So it is 1 is there. For 1, inverse Z transform is delta of n. Z by Z minus 3 is 3 power n u of n. This is constant, so minus 17 by 3. Z by Z minus 4 is 4 power n u of n. Okay, so this is the impulse response. Remember, this is the impulse response of the causal system. Causal system means, what is the meaning? Only u of n, that is only for positive values of n, h of n is present. Okay, for negative value of n it is 0. That is very important, because there are Z transform pair, we know already, we have seen the video. Z by Z minus 1, Z transform, inverse Z transform is u of n. Similarly, Z by Z minus 1, inverse Z transform is minus u of minus n minus 1. Okay, because see, for Z by Z minus 1, there are two inverse Z transform, u of n minus u of minus n minus 1. Okay, both are correct. Only thing, for this, the ROC is Z is greater than 1. For this, the ROC is Z is less than 1. Okay, so it should be very clear. If they say system is causal, we have to write the answer in u of n format. If they say system is anti-causal, you have to write the answer in minus u of minus n minus 1 format. Okay, this we have seen in a separate video. Along with the ROC, or all ROC only, Z transform is valid. Okay, for a causal system, this is the answer, impulse response. Next, we will find out the step response. Okay, we know already output is equal to system function into the input. For step response, input is step, x of n equal to u of n. So what is the transform of x of u of n? X of z equal to, for u of n, it is z by z minus 1. So you multiply with h of z into x of z. H of z, we know that is system function into the step response, I mean into the step input, unit step input, z by z minus 1. Okay, other things like okay, I am rewriting this. I am factorizing z square minus 7 z plus 12 as z minus 3 into z minus 4. As usual, bringing the z in the numerator to the left side in the denominator. This is very important step. I am stressing it again. Then only we can easily obtain the z transform pair, or take inverse z transform very easily. Only once we do this step only. This z is come here. Okay, right. Now, what are the poles? Z minus 1. So z equal to 1, z equal to 3, z equal to 4. We have 4 poles. They are real poles. So I can simply say a by, so 3 constant, a by z minus 1, b by z minus 3, plus c by z minus 4. Our objective is to find a, b and c. Then substitute those values, bring z to the right side, take inverse z transform. Thereby we will get the step response. Very, very clear. Okay, if you give the input as impulse, we will get the impulse response. If you give the input as step input u of n, we will get step response. Okay, now I'm solving for a, b and c. So this is a partial fraction expansion. Okay, based on the partial fraction expansion, I have got this expression right here. I have to cancel b and c term. B and c should be 0. So you can look here, z minus 1, z minus 1. So if I put z equal to 1, 1 minus 1 0, z minus 1 minus 1 0. So b and c will become 0. Okay. So put z equal to 1. We have this a equal to 1 by 6. Next, to find out b, I have to cancel a and c. So if I put z equal to 3, 3 minus 3 0, 3 minus 3 0, a and c will be becoming 0. So I can obtain b. B is minus 17 by 2. Similarly, to find out the c, I will cancel out a and b. So z minus 4 is there for both the terms. So z equal to 4, this will become 0. This here z equal to 4, this term will become 0. So a and b will become 0. So we have only the c term. Okay, so this thing you practice, right? You pause the video, write the from this expression, take the LCM. Okay, take the partial fraction, find out a, b, and c. Though it looks simple, this is a very important step. Okay, so once you obtain the a, b, and c, you substitute it. Okay, substitute here a, b, and c. So y of z by z, y of z by z equal to a by z minus 1, b by z minus 3, plus c by z minus 4. Substitute a, b, c values. Okay, now bring the z to the right side. Okay, now it becomes z by z minus 1, z by z minus 3, z by z minus 4. Now you can readily take the inverse z transform. So what is Z transform of 1 by 6? 1 by 6 is constant, 1 by 6. Z by Z minus 1 is U of n, minus 17 by 2 is constant, minus 17 by 2. Z by Z minus 3 is 3 power n U of n. Then 31 by 3 is constant. Z by Z minus 4 is 4 power n U of n. Okay, so this is the step response. This is the step response of the given system. Okay, like this, for any input you can obtain the response. Only thing that changes here, for impulse response we used delta of n. For step response x of z, I will put that in the place z by z minus 1. You change, just to change the input, we can obtain any output. Right. Next problem. Again, we are taking a system of difference equations. Clearly said it's a causal system. Causal system means h of n is, for negative values of n, it should be 0. Okay, for a causal system, the condition is h of n equal to 0 for n less than 0. This is the condition for causal system. Okay. Now we will see, that is we will find out what is the system function with its ROC. Then unit sample response. Sample response is also called impulse response. It's also called impulse response. As I said earlier, x is the input, x of n is the input, y of n is the output. Okay, the question is find the system function with its ROC, unit sample response, frequency response, that is your h of e power j omega. G per j omega, also its magnitude and phase angle. Okay, we will see it one by one. Okay, first thing we will find out what is system function with its ROC. For finding system function, only thing we have to take the Z transform of this difference equation. So y of n, Z transform is y of z. So 1 by 4 is constant. Y of n minus 1, so Z power minus 1. So phi of n, Z transform is y of z. So x of n, Z transform is x of z. 1 by 2 is constant. So x of n minus 1, Z power minus 1, x of z. Okay, so take x of z commonly outside, y of z commonly outside. So y of z by x of z is equal to this term. Here the numerator is z power minus 1, denominator is z power minus 1. So multiply both numerator and denominator by z. So if I multiply with z, I will get z plus 1 by 2, z plus 1 by 4. So this is the system function. Okay, very important step. They are asking, it is a causal system. For a causal system, ROC should be greater than the pole, greater than the largest pole. Here the pole is 1 by 4. Here the pole is minus 1 by 4, right? Magnitude of pole. Okay. So it should be greater than, magnitude of Z should be greater than 1 by 4. So this is very important. System function with ROC. If they say it is an anti-causal system, anti-causal system means becomes less than 1 by 4. That is very, very important, right? Since a causal system, ROC is greater than 1 by 4. Okay. Right. Now we will find out the sample, unit sample response or impulse response. So system function is output by input is what you got. So output is equal to system function into input. For impulse response, input x of n equal delta of t. So x of z equal to 1. So y of z equal to h of z. So h of z equal to this term. Okay, y of z equal to h. This is what the output. Okay, because the input is impulse. So x of z becomes 1. Again, very important step. You see, I am multiplying the numerator and denominator by z term. Multiplying numerator and denominator by z. Bring this z to the left side denominator. So h of z by z equal to z plus 1 by 2, z plus 1 by 4. So the poles are at z equal to 0, z equal to minus 1 by 4. So simple pole. So a by z plus b by z plus 1 by 4. Partial fraction. Okay, taking the LCM, we have to do the finding out a and b. As usual, z plus 1 by 2 equal to a into z plus 1 by 4 cross multiply plus b into z. I need a term. So if I put z equal to 0, this term becomes, it vanishes. So 0 plus 1 by 2 equal to a into 0 plus 1 by 4. So 1 by 2 equal to 1 by 4a. So a equal to 2. Next you put z. I have to cancel the, to find out b, I have to cancel the a term. So in place of z, I am putting minus 1 by 4. Minus 1 by 4 plus 1 by 4. This term becomes 0. So 0 into a is 0. So b into minus 1 by 4 is in place of z. I am putting minus 1 by 4. Minus 1 by 4 plus 1 by 2 is plus 1 by 4. So b is equal to, I think I made a mistake here. B is minus 1. B is minus 1. Okay. Right. B is minus 1. Right. Now substitute a and b values. A is 2, b is minus 1. Now bring z to the right side numerator. This z is coming to the here. Okay, multiply. If you multiply 2 into z by z, so it becomes z cancelled 2 minus z by z plus 1 by 4. Now you take the inverse z transform. What is the inverse z transform of 2 into delta of n? For z by z plus 1 by 4 is minus 1 by 4 whole power n u of n. So this is the impulse response or the unit sample response of the given system. Okay, now I without this step, see, I'm multiplying numerator denominator by z, right? Another way, without multiplying this also, I can get the answer. We will see what is that answer. Okay, both this answer and the next answer I am going to get, both are going to be the same. Okay, so I'll see next slide. We will see. So this is my h of z. Here I am not going to multiply with numerator denominator with z, right? What I have done is I have write this as z plus 1 by 4, 1 by 2 divided by z plus 1 by 4. Okay, so here I am multiplying with z power minus 1 and z power minus 1 and z. Okay, so see, z power minus 1 and z is 1. There is no change, right? Fine. Now what is the inverse z transform? Z by z plus 1 by 4 is minus 1 by 4 power 1 by 4 power n u of n plus 1 by 2 is constant. Okay, so see, we know what is z by z plus 1 by 4. Z by z plus 1 by 4 is this term, and z power minus 1 indicates a time shift of minus 1. So this term I am going to repeat it again, and in place of n I am going to derive by n minus 1, n minus 1. So this is the inverse z transform of this term. Okay, see, I am going to solve only for this. Whatever expression you get in the time domain, in place of n, I am going to put n minus 1. Suppose if it is z power plus 1, what happens? In place of n, I will put n plus 1. Z minus 2 means in place of n, I will put n minus 2. That much shifted. Okay, z power minus 1 means wherever n is there, n minus 1, n minus 1, n minus 1, n minus 1 I am putting. Okay, so this is the inverse transform. This is the impulse response or the unit sample response. This is the impulse response. Both are same. Okay, this is obtained in the previous slide, right? This is what here. Okay, right? By multiplying numerator denominator by z, I proceeded. I got this answer. Here, I used another method. Just I split this into 2, and I have taken inverse transform. Okay. Now this answer and this answer is the same. Let me check how. What is h of 0? H of 0 is minus 1 power 0 is 1, u of 0 is 1, so it is 1. Because if we put n equal to 0, u of minus 1, u of minus 1 is 0. So it is for this term, the answer is 1. Now you put here, what is h of 0? 2 into delta of 0. 2 into delta of 0 is 1. Minus 1 by 4 power 0, u of 0. That is 1. Okay, 2 minus anything but 0 is 1, u of 0 is 1, 1, the answer is 1. So we are getting both as 1. Likewise, you can try for other values also. Let me try for another value, h of 1. H of 1 means what happens? Minus 1 by power n, u of 1, plus 1 by 2, minus 1 by 4, 1 minus 1, u of 1 minus 1. Okay, right? In place of n, I am putting 1 now, right? Now we observe what is u of 1? U of 1 is 1. What is u of 1 minus 1 is 0? U of 0 is 1. 1 minus 1 is 0. Okay, so what we are getting here is minus 1 by 4 minus 1 by 4 plus 1 by 2. So the answer is plus 1 by 4. Let me check. I am getting the same answer here. h of 1, 2 into delta of 1 minus minus 1 by 4 power 1 u of 1. Delta of 1 is 0. Because delta of 0 is 1, delta of 1 is 0 minus u of 1 is 1 minus 1 power 4 is 1. So minus 1 by 4. The answer is 1 by 4. Okay, this is very important result I'm showing to you because see while writing a descriptive type answer you would have faced no problem because the faculty or the one who corrects your paper will be evaluating it perfectly. But you go for an multiple choice question MCQ type, if this answer is given this is correct, if this answer is given this is correct. Okay, we should be able to understand whatever method is given. This can be solved using splitting this like this too, or else multiplying numerator denominator by z. We have two answers. Both the answers are the same. That is what I have proved now. Similarly, you can check for h of 2, you get the same answer. H of 3, you get the same answer. Okay, I leave it as an exercise to verify completely whether this h of n and this h of n are the same. Now we will move into the how to find the frequency response. To find the frequency response, we have to go for the discrete Fourier transform. Okay, for to find go for the discrete Fourier transform. So this is the definition of discrete Fourier transform. If the signal is x of n, discrete time domain, capital X of e power j omega equals summation x of n e power minus j omega n. So this is z transform of x of n, x of z summation x of n z power minus n. So if you observe these two expressions closely, observe these two expressions closely, we can see the only difference is in place of z, if I put e power j omega, then these two are equal, or I can say these two are interchangeable. Just you put in place of z e power j omega. This is a very important concept. People will ask, what is the relation between z transform and discrete Fourier transform? Nothing but in place of z, if I put e power j omega, I can convert from z transform to discrete Fourier transform. But very important condition is, this is the condition, only when all the poles are inside the unit circle. Or else I can say the system should be stable. System should be stable. Then only I can go for this shortcut. Okay, or else this is not true. Clear? All poles should be inside the unit circle. In that case, I can go for, in place of z, I can substitute e power j omega. Right? Now, for this problem, this is the system function. So what are the poles? Poles are nothing but the roots of the denominator. Z plus 1 by 4. So pole is equal to minus 1 by 4. Minus 1 by 4 is inside 1. What is the magnitude of minus 1 by 4? It is 1 by 4. It is inside unit circle or less than 1. So this is a stable system. This is a stable system. Causal stable system, I can say. Okay, in that case, easily I can put, suppose the denominator will be z plus 4. If it is z plus 3, z plus 6, it is that means it is unstable. Z plus 1 by 4, pole is inside the unit circle, then it is a stable system. For a stable system, I can replace z with e power j omega to obtain the frequency response. So this is an application of Z transform, right? It's an application, right? From Z transform, I can find out the frequency response by just substituting in place of Z e power j omega, but only when all the poles are inside the unit circle. Okay, right. Now, in place of Z, I'm going to put e power j omega. E power j omega, I'm putting e power j omega plus 1 by 2, e power j omega plus 1 by 4. Okay. Now, what is e power j omega? Cos omega plus j sin omega plus 1 by 2, cos omega plus j sin omega plus 1 by 4. Then split into real part and imaginary part. So, j terms separately without j terms separately. So, cos omega plus 1 by 2 here plus j into sin omega, cos omega plus 1 by 4 separately plus j sin omega this time separately. So, this is called frequency response. Okay, for a frequency response, we have magnitude and phase angle. What is the magnitude? You know, real part square plus imaginary part square. Square root of real part. What is real part? Cos omega plus 1 by 2 whole square plus sin square omega divided by cos omega plus 1 by 4 square plus sin square omega. Okay, So I can expand this a plus b whole square. I'm expanding this. Okay, similarly I'm expanding the denominator term also. First I'm doing the magnitude. Okay, we know what how to take a magnitude, no? Right? Just like a power jd is there means magnitude is square root of a real part square plus imaginary part square. This is the magnitude. If this is the z, so magnitude of z is equal to this is the term. Okay, then what is here? You can see the terms like cos square omega plus sin square omega. Cos square omega sin square omega is 1. Similarly, cos square omega here sin square omega is also 1. So 1 plus 1 by 4, 1 plus 1 by 16, 1 plus 1 by 4, 1 plus 1 by 16. I got this. Okay, so this is the term. So these square roots I can take it as single square root. Then I can write this expression like whole power, instead of square root I can whole power 1 by 2. This is the magnitude response of the given system. Then what about the phase angle? Phase angle is obtained by, if you look at the, so this is the, what is the phase angle? I can say phase angle phi. Phase phi is equal to tan inverse of d by a. Or else I can say angle of z. Angle of z equal to tan inverse of imaginary part by tan inverse of b by a. Tan inverse of b by imaginary part divided by real part. That is the phase angle. Here the imaginary part is sin omega. So tan inverse of sin omega divided by this term cos omega plus 1 by 2 minus, if it's a denominator, if a division, angle becomes subtraction. If it is multiplication, angle becomes addition. Since this is in the division term, so minus tan inverse sin omega divided by cos omega plus 1 by 4. Tan inverse of sin omega by 1 by 4 is 0.25 omega plus cos omega. This is for the numerator term. This is for the denominator. This is the phase. Okay. So we have for the given system, we have obtained the both the magnitude and phase. Remember, Z transform can be converted to Fourier transform only when all the poles are inside the unit circle. Okay. Right. I hope you learned something useful from this lecture. Thanks for listening. Any doubts, please ask in the comment section. Wish you a happy learning. Jai Hind.